Okay, so we are on the last lesson of Unit 1. This will be the last day that you have in here to work on your missing assignments, because usually whenever we are having a lesson in algebra, you work on your assignment in here. Well, there's not going to be lessons for the next few days while we test and do all that stuff. So we will have more of those things that go in the assessment category for Math Lab, including like getting those study guides done and like more fun activity type things. So if you have been slacking, then today is the day to get caught back up. And there's really no reason you shouldn't be able to do that. An hour to do on average, like 5 questions, a homework assignment is not bad at all, especially when I'm here to help. And today, the lesson 15 was about comparing statistics for data sets. Because really, on the test, it's probably not going to say, what's the IQR of this data set? What's the standard deviation of this data set? It's not necessarily going to be like that. It's going to say, given these 2 dot plots, select all that is true. And some of it might be about standard deviation, some of it might be about mean, like you have to be able to compare and draw conclusions. So we did that by talking about and comparing measures of center and measures of variability. Table 6. But when it says what's the best measure of center, what are the only 2 answers that could make sense? Perfect. Median or mean would be a measure of center. How do I know which one is best? Table 3. Okay. Austin, you want to answer that? If it's symmetric, it's like the short version of that. So, if it is symmetric, which one do we prefer? The mean, because then the mean is really easy to see without having to do the math. I could tell you if it's symmetric, because it would just match the median. The median we prefer when it's not symmetric, because what has a really big impact on the mean? So think like your skewed data. Outliers, good. Outliers will pull the mean in that direction. So if I have an outlier to the right of all my data, will the mean increase or decrease? It will increase. If I add it to the left of my data, it would decrease. So that's why we care, because the median is better for skewed data. Think about measures of variability while I answer this. So in table 4, what are some measures of variability that we've talked about? And what else? Sorry, what? And then there's one more. Which one do we use when we prefer the mean? Table 1, can you tell me? Good. So again, when it's symmetric, you could also think. These are all associated. You need the mean for these. Like it is in the formula. Although we don't make you do it by hand, it's in the formula. IQR, you need what to find the IQR? Yes. It is Q3 minus Q1. What do you have to identify first before you identify Q3 or Q1? The median of the whole thing. So I think if you think about it that way, then you won't forget. Okay? At least that's what I think. And again, we use that for when the data is not symmetric. And that's the gist. That should help you answer a lot of the things on your test without needing to type it all into Desmos. But should you have time and want to check your answers, by all means, type it in Desmos. We taught you that as well. So this is the practice that I need you to get 80% or higher on while you're in here. There's no reason you all can't have at least one submission for this. But then, of course, you have today to work on anything else up to this point, including the study guide, if you're an overachiever and already finished the practice early. That would be the next thing that's. Question? One second. Right now, we're looking at lesson 15. Number 5 first, right? It looks like this. Okay, so then that means it's shuffled. So what does this first part of the question say? Okay. So the one that looks like this, because it is shuffled. So we have 20 students participated in a psychology experiment which measured their heart rates in 2 different situations. And what are the appropriate measures of center and variability to use? Complete the following to explain. So when it says measures of center, what are our options? Mean or median? So how do I know which one is the better one to use? So is situation A symmetric? So we would definitely use it for situation A, the mean. Is situation B symmetric? I would disagree. I think it is. If I draw a line of symmetry down here, isn't it a mirror image? So it doesn't have to be like in the middle of the number line. It just has to be where you can draw a line of symmetry, then it's still considered symmetric. So we would say the mean and standard deviation are more appropriate because the distributions are both symmetric. Which situation shows a greater typical heart rate? Typical values, would that be center or spread? Typical would be measures of center, okay? So we're asking basically which one would have a higher mean. Is basically what we're asking. So what's the mean of situation A? It is symmetric, so it would be wherever we could draw that line of symmetry. What's the middle of 85 and 90? Add them together, dividing by 2 if you need to. What's the halfway point between 85 and 90? Close. Okay, great. That's my, because remember when it's symmetric, the mean matches the median. So that's my mean of this one. What's my mean of this one? Of situation B? 85. So situation A has a higher measure of center, a higher mean, so a higher typical heart rate. Makes sense? And then which one shows greater variability? That means which one is more spread out. So what do you guys think? Which one's more spread out? And that's because this one goes like from 75 to 100. And this one goes from 70 to, oh wait, yeah, 70 to 100. So that's a little more spread out. So that's what I'm gonna go with. You could really do the math to know for sure. Sometimes they do stump me, but you're saying, you said B shows more variability? And according to the key, that's wrong, so let's see what it should be. We might actually have to do the math on that one to know for sure. Or it could be something wrong in the key, and I think it's something wrong in the key. These are not skewed. So I need to fix the key. Do that right now. They're definitely not skewed. To be symmetric. Everything else seems correct. So it will rescore, it just might take a few hours. To see the new reflection, but those were both symmetric. Questions on that? Yes? Okay, she asked one, so we're gonna do that one next and then we'll go to you. Can you tell me, Jalen, what the first part of that question was? And then like 11.5. So for this one, so the data set and summary statistics are listed. So here's my data set, here's my summary statistics. So they already found the mean, median, standard deviation, all of that. It says, how does adding 5 to each of the values in the data set impact the following? So while you could literally add 5 to each of these and then put it in a calculator and answer some of these questions, I do think some of it can be answered without it. Because if I'm adding 5 to every single number in the data set, will the shape change? It will not, the shape will not change. Because it'll just basically move the shape to the right 5. I'm changing all the values, so I'm moving the whole shape to the right side. So without even doing the math, I can tell you that. The values are all shifted 5 units to the right, because if I'm adding 5 to each number, as you go to the right on the number line, they get bigger, don't they? Right? So then let's go 5 to the right. For measures of center, that's mean or median. So if I'm increasing every single value by 5, would that increase or decrease the mean? It would increase it, same with the median too. So there, it's same amount of spread, all we're doing is adding 5 to every single one. So, yeah, it will increase it. And the other option said it would not change, so that's simply not the right one. And then the measures of variability. So it's not like I'm adding a data point that's making it more spread out or less spread out. I'm changing every single data point by the same amount. So am I changing the spread at all? I'm not. So without doing the math, I can tell you that, but you could have done the math. And it would still tell you all this, if you have added 5 data points and then done it in the calculator, this would line up. Questions on that? Yeah. Or do you have one cadence with a different one? What did it start with? The depth of 2 lakes, okay. So the depth of 2 lakes is measured at multiple spots. For the first lake, the mean depth is about 45 feet with a standard deviation of 8. For the second lake, the mean is about 60 feet with a standard deviation of 27 feet. NOAA says second lake is generally deeper than the first lake. Is he correct or incorrect? Correct. So you have to know the difference between center and spread. Which one tells me a typical value in the data set? Center or spread? Center. So things like mean or median tell me typical values. Things like standard deviation or IQR tell me how spread out it is. So when NOAA wants to know or says that the second lake is generally deeper, typically deeper, then I compare the mean to more than like the standard deviation. So if the first lake's typically 45 feet deep and the other one's about on average 60 feet deep, him saying that the second one is generally deeper is correct. Not incorrect, it's correct. Okay. So that's knowing whether to compare the means or standard deviation, so center or spread, typical values or how spread out it is. Good on that one? Amy? So on the left is the key one. Okay. About maple trees. Okay, so we have these two dot plots. We're gonna compare them. The means of the two data sets both equal blank feet. What would you guys say? 8, because both of these data sets are symmetric. That means I can actually tell the mean is gonna match the median and my middle of both is 8. Or you can do the math and it'll tell you that too. But the mean of both is 8. The standard deviation. The standard deviation of the first data set is blank the standard deviation of the second. So would you say this is, raise your hand if you think this one has a higher standard deviation. Raise your hand if you think it has a lower standard deviation. Because it is less spread out. It's like from the data 6 through 10 versus 4 through 12. It's a smaller range. So you would say the standard deviation of the first set is less than the standard deviation of the second. Next, we have complete what this tells you about the trees at these farms. So at Blank Farm, there's a wider range of heights. Which one had a wider range of heights? The second one. So I don't think there's any. The second farm. Good. Than the first farm. Where the heights are closer to one another. Let's make sure the key is right. And it is. So does that make sense? Okay, the lowest value, -6, is eliminated from this data set. Great test question. So my lowest value is eliminated from the data set, determine whether each statement is true or false. So would eliminating the lowest number increase or decrease the mean? It would increase it, because this was bringing the mean down, and now we're removing it, so it would increase the mean. Whether or not it increases it to 5.22 exactly, I think I would have to check in the calculator, but we'll check that. The median increases from 4 to 5. So if I eliminate this, I'm now just working with these numbers. Let's see what my middle number is. Okay, but yes, it looks like my median does increase from 4 to 5. If it was 4 before, I'd have to check real quick, so let me check. Yeah, because I'd have to average 3 and 5, and that would be 4. So that one's definitely true. The other one, I'd probably just have to check with my calculator, so that's what I'm gonna do. It will let me. Okay, hold on. Okay, so I'm just gonna see what the mean was before real quick. Okay, so the mean before was 4.1, and then when I erase the -6, it is about 5.22, so that is also true. So while I know for sure it increased, I had to actually do the math to know if it increased to that. So pay attention to that too. Any questions on how to use the technology and things? Okay, we might have time for one more, Massimo.
For this study guide, for question for that.
I don't think it's shuffled, so let me see if it's the same one that I have. You're on this one, right?
It's the 40.
No, like this one, that one, the study guide, the optional one?
Yeah.
Okay, well then it's probably is. Okay, tell me what it looks like. Okay. So. Standard deviation, which one is more or less spread out? So if it actually wants the value of the standard deviation, that's when you would have to use technology. I know it says don't use technology, but you'll have access to technology, so. Should just, we should just use it for that one. All right, might have time for one more. Anyone? Make sense now? Okay, so make sure, I mean, I did practically the whole assignment, so no one should have less than 80% on that. And hopefully you know why it is those answers, not just because you